All right, hello, Mr. Wahlberg. 5.3, we're going to look at similar figures and finding the unknown sides of them. We're going to be using proportions. If you don't remember how to do a proportion, I would recommend looking back on section 3.3 in your books and how to solve those. As it says here, to find an unknown sides of figures that are similar, a proportion is needed. Well, let's set up a proportion of these two triangles here. This triangle, obviously every side is given. This side is the only one given for this triangle. X is what we're trying to find. I'm going to set up a proportion of 4 over 16 because those two sides correspond with each other. What do we then know? We know that this side is 6 and this side is x. So I'm going to, because the 4 and the 6 are corresponding to each other, I'm sorry, not corresponding, part of the same triangle, I want to make sure I'm apples to apples, so my 4 and my 6 have to line up. Put the 6 over the x because I don't know that side. Well, then all you have to do, again, remember proportions. 6 times 16 and x times 4. That would get me 4x equals 16 times 6 is a 96. We then have to divide by 4 on both sides, and it gets me x equals 24. So that side is 24. And that would make sense. This side, look, is 16. This side is much longer. Not much longer, but it is definitely longer at a 24. So that would be that length. All right, let's do another example. Hopefully this is making some pretty good sense to you. Again, we always have to look, are the figures similar? In this case, it says they are. We have two sides here given and only one given here, and we're trying to find x. So I'm going to set up a ratio, 6 versus the 9. That's my ratio of those two corresponding sides. And then the 8 to the x. Now remember, the 8 and the 6 have to correspond, not correspond, I keep saying that. They have to line up with each other because they're part of the same triangle. So I'm going to put 8 over x. Real simple. All you have to do is solve. 6x equals a 72. What do you do from there? Divide by 6 on both sides. 72 divided by 6 is, of course, 12. So that side would be 12. All right, looking at another example of a problem that we can see in our assignment tomorrow. Just like we did last section on ratio of perimeters is always equal to the ratio that corresponds side lengths. Again, though, all we're doing is trying to find a missing value. They're telling you that the quadrilaterals are similar. The ratio of their perimeters is 12 to 5. Well, they're telling us what the proportion is, so it's 12 over 5. You have to figure out, though, how am I going to solve for x? If this side is 15 inches, look at the diagram, the figure, this figure is a whole lot bigger than that one. So when I compare the 12/5, 12 is over 5. That means this 15, again, we got to always compare apples to apples. The 15 is a bigger number than what x is going to be. X is going to be a whole lot smaller, so the x is going to correspond to this 5 on the bottom. I have to solve. 15 times 5 gets me 75. This equals 12x. Making sense here? Obviously, I'm running out of room here. Divide by 12 on both sides. These cancel out. 75 divided by 12 is 6.25. Obviously, my answer is C. Another example, actually a real-life problem that really actually does work, believe it or not. I've got two triangles here. You're looking at a palm tree. Here's the height. We don't know the height of it, but we do know that the shadow of it is 15 feet long. A person standing there is 6 feet tall, and they cast a shadow that is 3 feet long. So we have two ratios here that we can set up and solve to figure out how tall is this palm tree. Again, got to compare apples to apples. H and 6 go together, and 15 and 3 go together. So I'm going to set it up as H over 15 equals 6 over 3. Now, you don't have to do that that way. It's just you got to make sure that your 15 and your 3 line up with each other right here, and your H and your 6 line up with each other, because that's ultimately what we're after. Go ahead and I'm going to cross multiply these two right here. I'm going to get 3h equals 15 times 6 is 90. I'm going to divide by 3 on both sides, and I'm going to get h is 30-foot tall tree. Just kind of a fun example of how you can solve proportions with similar figures. Last example here goes back to last section, in which we can compare side lengths and figure out perimeters and areas. Well, this time we're going to work on area. We have two sides of a pool versus a volleyball court, 10/18. That's my ratio that I can set up here. That equals, I'm talking about the area of the volleyball court. Remember, you have to compare apples to apples, so the 10 and the 200 have to match up. I don't know the area of the pool, that's what I'm trying to find, over x. Just like last section, remember, we have to go ahead and square that whole ratio. That gets me 100 over 18 squared is 324. And that equals obviously the 200 over the x. Easiest way to do this at a cross multiply, I would just 100 times 2 is 200, so I'd multiply 324 times 2, and I would get 648. That would be my area of my pool here. Last thing here, tonight I would like you to try these 4 problems, and I will check them tomorrow when you get to class. Have a good night.